Assalamualaikum warahmatullahi wabarakatuh. My name is Nasriah Binti Mohamad Nasir. My metric number B051710148. My supervisor is Professor Madya Dr. Nur Izan Syarah Binti Husin. And my title is Effect of Parameters on Bit Dimension Simulation for Gas Metal Arc Welding Wire Arc Additive Manufacturing of Aluminium Alloy 535C. Introduction of Wire Arc Additive Manufacturing. Wire arc additive manufacturing is one of the options among numerous technology in wire and in additive manufacturing that can be used in build 3D metal part. Commonly, additive manufacturing is mainly used to fabricate 3D metal parts such as selective laser melting, electron beam melting, and direct metal deposition. Wire arc additive manufacturing utilize electric arc welding as heat sources and metal wire as the feedstock material. Conventional arc welding used in wire arc additive manufacturing is gas metal arc welding, gas tungsten arc welding, and plasma arc welding. Compared with other methods, gas metal arc welding based additive manufacturing has shown great potential due to several advantages, including high productivity, low cost, and strong bonding strength of the parts. In this project, wire arc additive manufacturing technology is applied to fabricate parts by deposit metal in to form the layer by layer process. Problem statement. The viewing of the surface appearance of part deposit using gas metal arc welding process for a better understanding on the influence of process parameters on surface roughness. The geometry of the layer is related to change in the heat dissipation of the different layers, interlayers temperature, the distance between the nozzle and the top surface of the parts, and the geometry and initial temperature of the substrate. Objective of this project: first, to select suitable parameters and their variables for wire arc additive manufacturing process of aluminium alloy 535C with gas metal arc welding. Second, to investigate through simulation the effect of currents, voltage, and transfer speed to work with and depth of penetration. Scope of project: size of base plate used 150mm length, 25mm width, and 5mm thickness. The variables of parameter used are current, voltage, and transfer speed that focus on load and height. Temperature distribution and weld bit dimension are being analyzed by using smart weld software. Full factorial method was chosen for analysis optimization of parameter. Methodology. First, the workpiece preparation. The jig has been prepared to hold position and support the base plate from moving during the deposition process. Prepare the wire aluminum alloy 535C with diameter 1.2mm and also prepare the base plate aluminum alloy 6061 that dimension 150mm length, 25mm width, and 5mm thickness. Next, welding system. Do a preliminary experiment involving delay time 0.8 seconds. The importance of the delay time, based on the previous study, the increase of the delay time significantly influenced the heat accumulation along the construction of part, and the preliminary experiment is produced without doing step height. In deposition process, sample set of parameter consists low and high parameter have been chosen to build one layer deposition. And the last one is optimization parameter. By using smart weld simulation, set up the input variable to get the response data. Then the data will be analyzed by full factorial technique design metric. The weld bit dimension was analyzed by use the data was collected in full factorial, which output variable are maximum width and maximum depth of penetration. So this is the result and discussion. This section describes the preliminary experiment that were taken with several runs to get the best selection of parameters and variables. In gas metal welding, the parameters and variables are one of the major parts that need to be focused and controlled to give out the best quality of deposition. So here are some of the preliminary experiments. For sample 1, use current 1 to 1 ampere, 21.9 voltage, and 0.4 meter per minute of transfer speed. The wall structure widened due to the height to the arc length is too short. The form of bead will expand in height and decrease in width as electrode initial drag extension increase. For sample 2, use current 140 ampere, 23 voltage, 0.4 meter per minute transfer speed. The sample failed because the temperature is too hot, cause the wire melt in contact tip, and cause it to clog. Sample 3, use current 1 to 1 ampere, 21.9 voltage, and 0.6 meter per minute transfer speed. The wall structure widened due no step height for every interlayer. The thickness imposed for each layer indicated by the step height between two subsequent layers. And sample 4, use current 140 ampere, 23 voltage, and 0.6 meter per minute transfer speed. The weld bead surface much better, but at the end process, the weld bead melt and flattens. This is due to height of temperature causes the wire melt in the contact tip. So from the sample of preliminary experiment, sample set of parameters have been produced. To implement the weld beads, it will use two aluminum base plate with two levels of parameter, which is low and high level. The low level involve 101 ampere of current, 19.9 voltage with 0.4 meter per minute of transfer speed, while high level involve the current of 1 to 1 ampere, 21.9 voltage with 0.6 meter per minute of transfer speed. Next, the deposition run for layer 2 to observe the increase in weld bead dimension and quality surface of part. To avoid height difference between the start and stop zone, the deposition orientation is zigzag with each layer in reverse order. To build the multi-layer, the process should involve step height for every layer. Step height is the distance raised from the end of the wire to the surface of part on each layer built. According to the Hong-Yao-Shen ETL 2020, if the distance increase, the height of the weld will increase and width will decrease. By using Smart Weld software, the parameter input, plate thickness, length, and width of the workpiece were set up into the software. After run the software, it will show value for maximum width and maximum depth. The maximum width and maximum depth for low level parameter are 4.25 millimeter and 2.13 millimeter. From the phase diagram, the melting point for aluminum alloy is 660 degrees Celsius. From the software, the temperature 650 degrees Celsius show is a fusion zone. Same goes to the analysis for high level parameter. After set up the software, it will show maximum width and maximum depth. The maximum width for high level is 5.38 millimeter, while maximum depth of penetration for high level is 2.69 millimeter. It also shows the weld bead dimension. The color red is heat fusion zone, while the blue color is heat affected zone. Full factorial method for gas metal arc welding analysis will be part of this project. The experiment design used for full factorial optimization was a combination of 9 sets of experiment. Arc current, arc voltage, and transfer speed have been chosen as input parameters, and width and depth of penetration is selected as output parameter. From this table, the parameter that affect the width is transfer speed because its value is closest to 0.01. The p-value of transfer speed is 0.151. From this Pareto chart of width, the graph closest to the red line is the graph that most influence the width. From the graph show the value of C, which is transfer speed that is closest to the red line. So the interaction of parameter C is the parameter that affect the depth, while interaction of the parameter for BC, A, AC, and B will give less impact to width. Next, the analysis toward depth of penetration. From this table, we can see the parameters that affect the depth transfer speed, current versus transfer speed, and voltage versus transfer speed because the p-value is closest to 0.01. The p-value for three parameters are the same, which is 0.275. While in Pareto chart, for depth of penetration, we can see the graph show the value of AB, BC, and C approaching the red line. So these three interaction of parameters are parameters that most affect the depth, while interaction of parameters for A, B, C, B, A, and AC will give less impact to depth. Optimization of parameter. The higher value for every parameter is the optimum value. From the both graph, it shows the optimum value for every parameter that influence the depth of penetration and width. Graph depth of penetration show the optimum value for current is 101 ampere, 21.9 voltage, and transfer speed is 0.6 meter per minute. While from the graph width show the optimum value for current is 1 to 1 ampere, 19.9 voltage, and transfer speed is 0.9 meter per minute. The discussion. The optimum parameter that most influence the depth of penetration is lower current, high voltage, and high transfer speed. According to Rakesh B, TITTLE 2013, welding current is a factor that will determine the penetration. Penetration also influenced by factors from welding speed and arc voltage. The second, the optimum parameter that most influence to the width is high current, low voltage, and high transfer speed. For a particular electrode diameter and extension, it was found that the bead width increased initially with current and welding speed. As a conclusion, the parameter of transfer speed give more effect for width and depth of penetration compared to current and voltage. Second, the dimension of bead influenced by distance between contact tip and surface of top bead. And last, if the welding direction is reversed for each layer, the variance of deposition height becomes small. If the welding direction does not change for each layer, the height becomes uneven and the starting point is higher than the ending point. That's all from me. Thank you.